Hey, my name is Angelo Mayorga, and this is my presentation, Concrete and its Ingredients. Brief history about concrete. The earliest known use of concrete was in the Middle East. It was around 6500 BC. These structures included concrete floors, underground waterproof cisterns, and small rubble wall houses. In 3000 BC, Egyptians used 500,000 tons of mortar to build the pyramids. In 600 BC, Romans began to perfect their cement mixture, and by 200 BC, they actually had cement that could cure underwater. This allowed them to build, really incredible feats of architecture like the Colosseums, aqueducts, cisterns, bridges. Unfortunately, this knowledge of concrete was lost after the fall of Rome, and it wasn't until the 18th century when English inventors began experimenting with concrete again that we regained this knowledge. And in 1824, Portland cement was invented and patented by Joseph Aspen. Now, over the years, we have developed techniques and different types of concrete that have allowed us to build bigger and better structures such as skyscrapers, bigger bridges, better roads, and many more things. Now, the makeup of concrete. One thing to mention is that cement and concrete are sometimes used interchangeably, and it's important to mention that they are not the same thing. Cement is an ingredient inside concrete. The three basic ingredients of concrete are cement, water, and aggregates. The aggregates are fine and coarse, such as sand and gravel or crushed stone. Aggregates make up the majority of the mix. Percentage-wise, they make up about 60-75%. Water makes up about 15 to 20%. Cement about 15%. Air bubble, sometimes it depends on the type of concrete you're trying to make, but it's usually 2 to 8%. Now, the manufacturing and production of cement. First off, you have to get the raw materials. These raw materials consist of combinations of limestone, cement rock, marl, oyster shells, shale, clay, sand, or iron ore. So these raw materials are transported to a crusher and they are crushed. They are then taken to a secondary crusher, crushed again. Each of these raw materials, they are stored separately, and they are then taken to more grinding, another grinding mill. So these raw materials, they are then proportioned correctly according to what type of cement the factory is making, and then it's grinded furtherly more into a finer substance, and it's dried and then mixed in the silos, and then this mix is then taken to a kiln. This mix is then burned in a kiln at a temperature of about 2700 degrees Fahrenheit, and this material turns into a rock-like substance. It's called clinker. So then the clinker is taken to another crusher. It's then pulverized into a very fine powder. And this powder is what we know as cement. After that, the cement is stored, it's packaged, delivered to retailers and manufacturers. There are many different types of cement. Uh, each of these serve multiple purposes. I mean, they each serve their specific purpose. These types of cement are established by the ASTM C150, which is a standard specification for Portland cement. The types of cement are as follows. We have Type 1, normal, Type 1A, normal in training, Type 2, high early strength, Type 3A, high early strength air in training, Type 4, low heat of hydration, and Type 5, high resistance to sulfate attack. Type 1 cement is the most used in construction. Types 2 and 5 is used in environments where contact with sulfates is in high in concentration. Type 3 has fast curing, and Type 4 is used in dams since there's a very high amount of heat emission. Uh, Air and training cements are used in order to improve the workability of concrete and to increase the resistance against freezing and thawing cycles by allowing the water to expand and contract in the microscopic bubbles inside the concrete. This type of concrete is mostly used in exposed areas or projects such as pavings like sidewalks, driveways, etc. Um, so the water and aggregates include sand and stone. They're very abundant in some parts of the world. The strength of concrete really depends on the type of aggregates used. The aggregates and water must be clean of any chemicals or minerals that could affect the strength of a concrete over time. like salt or organic compounds. For instance, if you have salt in the water or the or minerals, it can cause damage because salt causes corrosion to things like iron or steel. They must be proportionally sized and properly selected in order to achieve close packing of the particles. This is important so the concrete can achieve its maximum strength. Uh, so besides these basic ingredients, there are other ingredients such as admixtures. There are different types of admixtures and they each serve a specific purpose. There are area training mixtures, water reducing admixtures, accelerating mixtures, workability agents, shrinkage reducing admixtures, color agents, corrosion inhibitors, freeze protection, and extended set admixtures. Uh, Air and training admixtures increase the workability of concrete during placement and make it more resistant to freezing cycles. Water reducing admixtures are self-explanatory. They basically reduce the amount of water needed in the mixture. Accelerating mixtures cause concrete to cure more rapidly. Workability agents make concrete easier to work with during placement. Shrinkage reducing agents reduce how much concrete shrinks as it cures. And color agents add color to concrete. Corrosion inhibitors, they prevent corrosion. Freeze protection protects against freezing. Extended set admixtures, they prolong the curing time of concrete so you can work with it longer. There are many types of concrete that exist. There's honestly too many to list in this PowerPoint, but to keep it short, the main types of concrete that we use today are reinforced concrete, precast concrete, air and train concrete, pumped concrete, shotcrete, and plain concrete. Reinforced concrete is used primarily in objects that require increased tensile strength, such as high-rise buildings, foundation supports, bridges, things like that. Precast concrete are just concrete units that can be assembled on site. You see these as panels, walls. You see those gray poles with electricity. Those are precast units. Air and trade concrete is used in projects that are exposed to the outside elements and are subject to freeze and thaw cycles. They have the microscopic bubbles. You have pumped concrete, which is concrete that is used when it's pumped long distances, usually used in high-rise construction sometimes, and it must have a certain density and composition to allow it to be pumped far distances. If it's not, if you use ordinary concrete, then you can have complications such as bleeding or separation, things like that. Shotcrete is concrete that is used when you are trying to cast complex shapes. The concrete shot into a frame or a formwork, and at the same time it is compacted because of the force that it's shot at. Plain concrete is basically just that. It's plain, it's average concrete that you may use for a home project. It has normal strength, doesn't contain reinforcement. It's used for pavements and buildings where there isn't much tensile strength needed. Pros and cons of concrete. It's a very durable building material. It's fire resistant. It's affordable because of how easy accessible it is. The materials are really easily able to get. It's low maintenance. It's wind and water resistant. It's a good insulator for temperature and for sound. Cons. It's heavy and difficult to transport. It's slower to build with. Has this thing called efflorescence, which is white fluffy material that appears on concrete. And it has low strength house tank by itself, so this creates the need for the use of reinforcement, and reinforcement can be pretty expensive. Concrete is also susceptible to cracks because of shrinking during curing, or because again of its low tensile strength. The greatest architectural feats in human history have been made out of concrete. These are some outstanding examples of concrete architecture. The Sydney Opera House, one of my personal favorites because of its shell design. The creator of the designer of the architecture of the Sydney Opera House, Jordan Utzon, actually won the Pritzker Architecture Prize, which is like the highest recognition an architect can get because of his design. A really incredible feat we have is the Three Gorges Dam. This is the largest dam in the world. It's located in China and it is 7,660 feet long and 607 feet tall. It incorporates 28 million cubic meters of concrete and 463,000 metric tons of steel into its design. It also generates 22,500 megawatts of electricity, which also makes it the most productive hydroelectric dam in the world. And finally, we have the Burj Khalifa, really incredible feat of architecture also. It's the tallest building in the world with a height of 2,717 feet. So in conclusion, concrete is a very affordable and obtainable material as compared to wood, steel, or other materials. It's very versatile material also. Uh, One thing to mention also is concrete is actually the second most used material in the in the earth by humans after water. So it just proves how much we deem it a successful building material if it's the second most used material right behind water. Uh, that's it. That concludes this presentation.